FlexCar is a collaborative initiative that brings together the HDM, Mercedes, and other prominent corporations. The primary objective of this joint venture is to establish an open vehicle research platform, laying the foundation for next-generation mobility solutions. Situated at the Arena 2036, the project incorporates an electric rolling chassis and a state-of-the-art mixed reality simulator setup. Utilizing this technical framework, the goal is to explore diverse research areas, such as the interior and cyber-physical entry. One of the topics within this area revolves around interior-related use cases, specifically examining the prospect of working while driving in the context of an autonomous shuttle. As part of the innovation project, this study was initiated to develop and test interaction concepts with 2D and 3D visuals in an autonomous vehicle. The primary goal of the study was to define the single best or best combination of the examined input concepts for 2D and 3D interaction, which included moving, scaling, and rotating objects in 2D and 3D space. To address this question, a mixed reality prototype was created in Unity. The prototype utilized the Vario XR3 glasses for a virtual presentation, as well as haptic elements like real car seats to provide an immersive experience to the users. In addition to the mixed reality setup, a custom middle console was modeled and built to provide a physical basis for the tested input devices. For the 2D display, a virtual screen was placed at the user's eye level. For 3D, a virtual table was placed in front of the user's seats, serving as a projection surface. The study was divided into two key phases, a pre-study and a main study. During the pre-study, initial exploration and testing of 3 interaction concepts took place. The input concepts included a touchpad, gesture control, and a space mouse. The effectiveness of each input concept was evaluated through 2 distinct use cases, which can be assigned to the field of architecture. The first use case took place in a 2D environment, where participants were asked to locate and click on a red highlighted house on a map. In this scenario, the goal was to assess how well the input concepts performed in a simple 2D interaction task. The second use case involved a more complex 3D scenario. Participants were presented with a 3D house object and were tasked with counting the number of doors on it. It is important to note that these use cases were merely employed as examples. The overarching concept can be applied to various areas of 2D and 3D interaction, extending its applicability beyond just architects. Before conducting the test, demographic data and previous experience were gathered from the participants. During the test, the Think Aloud method was employed, allowing participants to verbalize their thoughts and impressions as they interacted with the system. For each of the individual input devices, participants filled out the User Experience Questionnaire and the NASA Task Load Index Questionnaire to assess their user experience and perceived workload. Finally, at the conclusion of the test, participants were given a questionnaire to evaluate their overall experience with the entire system. Based on the pre-study evaluating input devices for 2D and 3D use cases, several key findings were identified. Contrary to initial expectations, the Space Mouse received positive feedback from participants, regardless of whether it was used for 2D or 3D applications. Users appreciated its fluid interaction and the ability to perform precise movements. The haptic aspect of the Space Mouse may also have contributed to its positive reception. The touchpad was found to be suitable for 2D applications but encountered limitations in 3D scenarios. Unlike a touchscreen, the touchpad served as an input device only, with the visual representation located elsewhere. This disjointed experience affected its effectiveness, particularly for movements in 3D contexts. Regarding gesture controls, one key finding was that participants showed a clear preference for intuitive and familiar gestures that closely resembled real-world interactions. Conversely, unfamiliar and unintuitive gestures were not well received by participants. Such gestures were described as challenging to remember and execute, leading to frustration and dissatisfaction. However, the hedonic quality of gesture controls was reported to be very high. This positive emotional experience further emphasized the significance of providing a user-friendly and immersive interaction with the system. Another crucial aspect that influenced participants' perception of the system was the quality of implementation. Based on this feedback, Subsequent studies focused on making adjustments and improvements to enhance the implementation quality, ensuring a more positive user perception. Based on the findings of the pre-study, it was decided to test a system combining the Space Mouse and gesture control for the final part of the study. Here, users could use both the Space Mouse and the gesture control at their own discretion to interact with the 2D and 3D visuals. In addition, the use cases identified in the pre-study were further developed and improved. The 2D use case became more complex, requiring participants to first select a city from a horizontal slider. Subsequently, they had to search for a street and then choose a red house. As for the 3D use case, instead of a house, a cross-section of an apartment was used, and participants were tasked with finding differently colored objects. Similar to the pre-study, the Think Aloud method was employed during the tests, along with the use of the User Experience Questionnaire, the NASA Task Load Index, and a concluding general questionnaire about the system. For the main study, the following key findings could be found. The combination of gesture control and the Space Mouse complements each other quite well. Gesture control allows for quick but imprecise actions, while the Space Mouse is better suited for slower and more precise work. However, there is no clear tendency regarding which input method is preferred for 2D and 3D tasks, as preferences are mixed, even within the various use cases. Participants generally find gesture control to be cool and exciting, as it introduces a new and enjoyable way of interacting with the system. The improved implementation and better defined gestures in the current test have been positively received compared to the pre-test. However, some users perceive gesture control as tiring, even after just a few minutes of usage. Therefore, the option to switch to the Space Mouse is appreciated, as it offers an alternative means of control. Another challenge with gesture control lies in the variability of execution, such as slight differences in making a fist, leading to gestures not being recognized accurately. To address this issue, it is crucial to include a wide range of gesture variations in the gesture database. Additionally, unintentional gestures, such as when putting down the hand, pose another challenge that needs to be taken into consideration. Another issue arises in recognizing the end of a gesture. For example, the gesture for moving an object had a crucial tracking point to determine the gesture at the index finger. When ending the gesture by opening the hand, the tracking point at the index would move up a bit, leading to a slight unwanted shift, which made accurate movement difficult in some cases. In conclusion, the empirical findings indicate that the integration of the Space Mouse and gesture control demonstrated promising potential for facilitating interaction with 2D and 3D visuals. The observed positive reception of the improved gesture implementation, although not perfect yet, and its perceived novelty underscore its appeal in user experience. However, it is important to acknowledge the need for additional testing in diverse use cases to confirm and generalize these results effectively. Further investigation will allow for a deeper understanding of the strengths and limitations of this interactive paradigm. Together, these insights contribute to the advancement of interactive technology, opening new avenues for innovative and engaging user interfaces in the realm of visual computing in autonomous vehicles.